Welcome to the Enthalpy Calculator app, a groundbreaking project developed in Visual Studio. This app is not just a calculator. It is a comprehensive tool designed to assist students in exploring and understanding the fascinating world of enthalpy and heat capacities. The Enthalpy Calculator from Heat Capacities, or ECHC, is a Visual Basic Studio project with a distinct purpose. It is tailored to assist students in calculating and visualizing enthalpy values for solids, liquids, and gases at different temperatures. This user-friendly tool aims to simplify the intricate concepts of heat capacities, providing an intuitive interface with advanced features. The user interface of the calculator contains, first, the main interface and the submain interface. The submain interface then redirects the user to the solids UI, liquids UI, and gases UI. Now, let's explore the key features that make this calculator an indispensable asset. First is the enthalpy temperature graphs, which generate clear and informative graphs illustrating the relationship between enthalpy and temperature for solids, liquids, and gases. It visualizes data trends with ease and clarity. Next is the temperature converter, where users experience flexibility in data entry with our versatile temperature converter supporting conversion from Fahrenheit, Celsius, or Rankine units to Kelvins. Next is the Heat Capacities database, where users access a comprehensive database for solids, liquids, and gases. They can explore heat capacities for various chemical species, enriching their calculations with reliable reference values. In the enthalpy calculator, we employ fundamental principles and equations to ensure accurate and meaningful thermodynamic calculations. Let's delve into the underlying concepts. Enthalpy is a pivotal thermodynamic concept representing the total heat content of a system under constant pressure. It provides a comprehensive measure of the system's energy state. Heat capacity reveals the amount of heat a substance can absorb, offering insights into its ability to undergo temperature changes. The central equation guiding our calculations expresses the change in enthalpy, or delta H, as an integral with respect to temperature T as shown. The integral CP/dt incorporates the heat capacity at constant pressure. The equation further expands as a polynomial function of temperature T, with A, B, C, and D representing constants, and R standing for the ideal gas constant, which is set to 8.314 joules per mole Kelvin in this calculator. However, like any other tool, the enthalpy calculator has its limitations. Developed exclusively in SI units, it requires temperature in kelvins for consistent calculations. The calculator yields enthalpy results in joules per mole, requiring users to convert values if different units are desired. It's essential to note that the calculator is designed for individual chemical species and lacks the capability to solve for total enthalpy in chemical reactions. The database of chemical species is constrained to the contents of Introduction to Chemical Engineering Thermodynamics, limiting the range of substances available for enthalpy calculations.
Welcome to the Enthalpy Calculator, a powerful tool designed for precise calculation of the enthalpy values for solids, liquids, and gases. So let's explore the main features of this Visual Basic project. Upon launching the application, you'll find the straightforward Start button that will lead you to the Enthalpy Calculator. So this submain interface is divided into sections. The first is the temperature converter. So it converts a certain unit into a Kelvin because Kelvin is used in this calculator to solve for the enthalpy. So let's say if we're given with 300 Celsius, then you compute that's the given value, and also if we're given with Fahrenheit and also for Rankine. So that's it for the temperature converter. Next is the settings. So these settings customize your interface by choosing various color themes, ensuring a personalized and visually comfortable experience. So let's say for aquatic, dessert, night sky, dust, and default. Next is the phase. So this phase consists the solids, liquids, and gases. So before we proceed to those, let us show you the other option that we can see here, which is the help, which shows the specifically user guide interface for this calculator. So here are the steps and also for some other notes. So to be ensured that for computation, the developed using data are from the books of the Introduction to Chemical Engineering Thermodynamics by Smith, Van Ness, Abbott, and Swihart. So that is where the values we use for this calculator. And about, which is about the creator of this calculator. So let's first see the interface for the solids. So here is the interface of the solids. We have here some chemical species, initial temperature, final temp, compute reset, and the database. Yeah. And we have also here the output, the IDs, the species, the temperature max, the value for A, B, C, D, and also for the output, which is the enthalpy. So we also have here the theme that you can change based on your preferences. So let's return and let's go to the liquid. It's also same for the liquid, the same contents, but different chemical species. And here is also the database. And lastly, for the phase is the gas. So let's try considering example for the gas phase. So let's say let's go with ethyl benzene. So we must input an initial temperature within the valid range. So any input outside the range or below 278 will prompt an error. So let's say we have 200. This prompts an error that it is not within the range. So let's try that is 300. And also for the max temp, we must also input temperature that is also within the range. So that according to the data, the Tmax should be at exactly equal or less than 150. So if we put 15101, it will prompt an error. So let's say let's put 1215 Kelvin. So let's compute. So here is the value for the enthalpy. So we can see that the button for the generate graph is being able. So if we click the generate graph, it will show and visualize the results with the enthalpy versus temperature diagram. So we can see that the red point here represents the intersection of the maximum temp, which is the we put is the 1215, and the enthalpy that we calculate, which is 232,154.77 joules per mole. So it is here, and the Tmax is within here. So that is for the enthalpy calculator. So it will reset, it go back to the reset form or the main form. So it's the data and return. That is all for our enthalpy calculator. Thank you.